Hello everyone, welcome to Coders Camp. We are at 10th day of June Lead Code Challenge and the problem we are going to cover in this video is My Calendar 1. So we have to implement a My Calendar class to store our events. So it has two methods. My Calendar is used to declare your data structures and the other method is booking. So here the book method has two parameters, that is the start date and end date of your event. And the return type is a boolean where you have to return true or false based on whether you can book the event or not. So here we can book the event based on the start and end date. That is, if no two events are overlapping, then we can return true. If not, we can return false. So let's understand this problem with an example. So here is the first input of the event, starts at the day 10 and end at the day 20. So we don't have any other events yet. So this event can be true as there are no overlapping events to it. So the next input comes in starting with the date 15 and ending with 25. So if you see, there is already an event happening during 10 to 20. So in that case, we cannot start a new event which is starting in between of that event. We either have to end it before 10 or have to start after 20. So this is not possible. So this event cannot happen. So we have to return false. And there comes the third input starting at 20 and ending at 30, where our first event ends at 20. So we can start our third event on 20 and finish it off with 30 without any interruption. So this event can happen. So we are going to return true. So how are we going to approach this? So we can have a list which is going to store the start date and end date to maintain the events that is happening. And every time a new event is entered to our method, we are going to iterate this list to check whether any of the date are intercepting the current incoming event. If that intercepts, then we can return true. If not, we can return false. But this is actually going to take big O of n square time complexity, as we are going to iterate the list by using big O of n time, and for every event that enters we are going to iterate the list. So overall it's going to take big O of n square time complexity. So how do we do it in an optimized way? So if you see the hint they have given, it says store the events as a sorted list of intervals. If none of the events conflicts, then the new event can be added. So we are going to implement this only. As per the hint, we have to store our events based on the sorted order. So the best candidate to store the events in sorted order in Java is going to be TreeMap. So we are going to get the help of TreeMap to store our events start date and end date. So this maintains the data structure, but how do we find whether we can make the event or not? So there comes the help of ceiling key and floor key functions. You must be familiar with these functions by now because we have used in two other videos previously while we implemented TreeMap. So ceiling key is going to return the greater or equal value in the list or in the tree map if we pass a key. Same way, floor key is going to return the less or equal value in the list. So now comes our first event, starts with the 10 and end with the day 20. So here in TreeMap, we are going to store this as a key value pair where the starting date is the key and ending date is the value. So now our first event enters and we are going to perform the ceiling key and floor key. So it is going to return both null because till now we don't have anything added into our TreeMap. So both are null. So in that case, there is no intercepting dates to this current event. So in that case, we are going to return true for the first event. So then comes our second event, 15, 20. So we are going to perform the ceiling key and floor key methods for the key of the tree map. It's nothing but the starting date. So our ceiling key method is going to look for equal or greater values. But here the only single entry in a tree map is 10, 20, where 10 is the key. We are going to check only for the key, not for the value. So here if you check for 10, 20, there is no equal or greater value to 15 because there is no 15 or there is no greater value than 15. So the only value in the tree map is 10. So in that case, the ceiling key of 15 is going to be returned as null. And now the floor key of 15 is going to be checking for the lesser or equal value. Again, there is no equal value, but there is a lesser value than 15, which is 10. So the floor key of 15 is going to be 10. So now by using these values, how do we check whether it is intercepting with already happening event? To do that, we are going to check these two conditions. So these two conditions are nothing but if we want to perform an event, then its end date must be less than or equal to starting date of any other events. That is, our event must end before any other event start. Same way, our starting date must be greater than the ending date of any other event, which is nothing but, in other words, our start date must start after ending all other events in the list. So now to check these two conditions, we know what is the end date and starting date of the current event because those are the parameters being passed to the method. But how do we check the starting date of other event or ending date of other event happening? So there comes the need of ceiling key and floor key. So here the starting date of the other events is nothing but the CL key value returned from the tree map, because our CL key is going to return the nearest equal or greater value from our key. So if suppose it returns any value and that is actually greater than the end date, which means our current event end before any other date or event that is happening. If suppose the starting date of any other event returned is less than the end date, that is if the end date of the event is 20 and the return date is like 16 or 17, in that case there is some other event which is happening. So if this condition is satisfied, then in that case we can start our event and we can put this into our map. Same way it has to satisfy the other condition as well, that our starting date of our event must be greater than or equal to end date of any other events. So how do we get the end date of any other events? That is get of the floor value returned. So why get of? Because the value stored in the tree map is the end date, not the starting date. So we are going to get the get of floor value because the floor value is nothing but the nearest lesser or equal value. So here the nearest lesser or equal value is 10. So what is the end date of that event, which is 20? So if our starting date is greater than that end date, which means we can start our event after that event completes. If not, if it is a lesser value, then in that case our date interrupt with the already happening event. So if these two conditions are satisfied, then in that case we are going to add that event to our tree map. If not, we are simply not going to add it and return false. And we are going to perform the same check for every other event entering into the function. And if this satisfies, then we are going to return true and add that to our map. So why do we need to add that? Because we have to check further events whether this event is interrupting that event or not. So hope you're understanding this solution, and this is going to work in big O of n log n time complexity as we are performing the operations, that is inserting the values to a tree map, that is going to take login time, and we are going to check these ceiling key and floor key every time for the new event entered. That is overall it is going to take big O of n login time complexity. So let's go to the code now. So yes, as we explained, we need a tree map which stores the start and the end date, and we have a constructor to initialize our data structure. So inside our book method, we are going to find the ceiling and floor value of our start key. So here I'm declaring this as an integer instead of just int, because this ceiling key and floor key sometimes return null value. So in order to handle that, we have to declare it in integer. So now we are going to check that condition, that if our floor value is first null, so this condition is nothing but whether any other event's end date is less than or equal to start. And this condition is nothing but whether our end date is less than any other event's starting date. So if both of the conditions are true, then in that case our event is not interrupting with any other event present in the tree map. So in that case, we are going to add that to our map. And if we can successfully add that, which means we can return true that this event can happen. If not, finally return false. So yes, let's run and try. Yes, so let's submit. Yes, the solution is accepted and runs in 21 milliseconds. So thanks for watching the video. Hope you liked this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.